Hello, my name is Joe Kizis and I'm president of Bravada Gold Corporation. Today I'm going to speak about the Baxter project located in the Walker Lane Gold Belt of western Nevada. For several years, Kinross held the property as part of an earn-in joint venture agreement with Bravada. Late in 2017, Kinross returned 100% of the project back to Bravada. So what did they do? What did they find? And how does that affect the project going forward? They've done an enormous amount of excellent work on the project. They drilled 3 programs of RC drilling, which included 54 holes, and they were successful at discovering shallow oxide mineralization at the center target. So Kinross is looking for a large deposit, and they felt like they weren't being successful, and they returned the project to us. That doesn't mean there's not a significant deposit yet to be found. And after reviewing all of the data, I feel like there's excellent potential still in the project for both high-grade, underground, potentially mineable mineralization, as well as shallower oxide, open pitable type mineralization. So let's take a step back and look at why I like the project. The Baxter project is located in western Nevada in the Walker Lane Gold Belt. That's one of the major gold belts of Nevada, one of the 3 large major gold belts. And in blue, we see the targets at Baxter. To the southeast, we have the historically mined Bruner district. It's currently being developed by Canamex. They actually are permitting a heap leach site just to the southeast of our project. To the northeast is Bravada's Highland project. It's now subject to an earn-in joint venture with Oceana Gold, which we signed in December of 2018. On this slide, we zoom in a little bit. We can still see the targets there in blue highlighted, and you can see the large claim block that we have. The colors there are geology. It looks complex, and it is. In fact, that's always a good thing for gold deposits. The important thing to know here, there are a number of intrusive bodies that could drive the hydrothermal systems that create the gold deposits. Maybe even more interesting to the average investor are the grades. Some of these rock chip samples that were collected. The largest or the biggest sample, highest grade sample, was the sample at 43.7 grams per ton. But as you can see, if you look at the little black figures there with the values, there's a 4.5, a 7.8. There's a 21, 39. There's a significant number of high-grade samples there. There are 2 basic areas where mineralization seems to cluster. On the south end, there are several targets there. We'll look at those a little bit. On the north end, the center target will look in more detail. In general, though, basically what we're seeing is that the top of the system is located in the north, and there's more and more erosion as you go to the south. In the southern area, we can see some textures very well developed because this area is more deeply eroded into the vein systems. So at Chugiak on the upper slide there, the classic quartz after calcite texture is shown here. This is sometimes called potato chip texture because it looks like a bag of potato chips have been smashed and thrown on the ground. This is indicative of boiling, very well developed in the Chugiak area as well as other areas. Baxter, of course, is where there was some previous historic mining, very small scale historic mining. The west vein area has some really interesting textures, these hydrothermal breccias that are coated with adularia crystals. Adularia is a potassium-rich mineral. It's very diagnostic of these low-sulphidation vein systems, and it coats these fractures, and in many cases, some of these little boulders that are caught up into these hydrothermal breccia zones. The center target is located at the north end of the property, and it is the least eroded part of the system. Post-mineral basalts cap the system. They're absolutely fresh, and yet going downhill, deeper eroded into the system, we see a large area of light-colored rocks. This is clay alteration. Below the basalt cap, we have sinter that's exposed. More deeply eroded in the system, we have these very distinctive hydrothermal breccias. In the light blue dashed area, there's one prominent outcrop that I show as a blow up on the lower left. You can see it's very bouldery. There's a large boulder to the right of the rock hammer. Taking a look to this further to the lower right hand side, you see that same boulder is actually composed of a number of other boulders. So what we have here is a multi-stage breccia, probably driven by gases that are coming off boiling fluids at depth. The fact that it's boiling and having multiple episodes is very attractive, because multiple episodes of boiling often provide multiple periods of gold mineralization. This was, as I mentioned, probably mostly gas derived, but there is some quartz that is indicative of a hydrothermal fluid. There's quartz after calcite indicating that fluid was boiling, and in an assay that we took of that material, it contains over 2 grams per ton gold. So even at this high level, there's a little bit of leakage upward from the gold-bearing fluids. The photo was taken from the area, the arrow in dark blue there, looking to the west, past the center horizons to the basalt-capped hilltop that's dashed there in purple. Beneath that basalt cap, though, the unmineralized rock, is a highly altered rock called the rhyolite breccia, which is an eruptive center. Highlighting the drill intercepts, you can see that they surround the red dashed area, which is the rhyolite breccia. Let's look at the gravity geophysics. Low density is generally caused by alteration, and we can see that there's a large blob of low density that basically sits underneath or slightly to the south of the exposure on the surface of the rhyolite breccia. The mineralization surrounds that. We also see that there's a magnetic high that is related to the mineralization. Here we look at a detail of that magnetic feature, and we're going to rotate it along the line of that yellow dash. So in this partial rotation, what we see there is that even though there's a point in the center of that magnetic anomaly that's very high, that's actually the capping basalt, and basalts are very magnetic. If you had a magnet, you could stick it to the side of the basalt, it would move the magnet. But that's really hiding a feature that's significantly more important, and that's the circular low that actually sits underneath and is related to the rhyolite breccia. As you can see, the majority of the mineralization surrounds that low. When we complete the rotation and add the low density feature, we see that it sits underneath the capping basalt, basically sitting underneath the rhyolite breccia, and then circled there in white. It's a little bit difficult to see through the density alteration, is hole number 17-07, which is one of the stronger mineralized zones that was encountered. This slide shows our geologic interpretation. So the shallow oxide resource that was the subject of the Kinross drilling appears to be the bleed out along permeable volcaniclastic sediments. That makes sense. Fluids migrate laterally and deposit their gold along the way. The driving force, though, is really what we're most interested in, and the rhyolite breccia, I think, is a good guide. Beneath it, there's strong magnetic destruction. There's low density. Undoubtedly, the larger magnetic feature is some sort of a buried intrusion, and the surface expression of that is the rhyolite breccia. So that's probably where the driving force lies, and that should be where the better grades are. Hole 7 is maybe a piece of that, and maybe we caught the edge of one of the vein systems. There's still some there's still some work that could be done to identify where the actual high-grade zones would be, and that would include some grid soil sampling, because there's very little sampling in the area of the rhyolite breccia right now. and perhaps some IP or gradient IP to identify some of the structures that should be tested with drilling. So we're still very excited about the project. It's going to require some additional work, but given the grades that we see in the system there, this is a vigorous gold-rich system, and those are the ones that can produce some bonanza grade gold deposits.